Hello everyone. Today we are moving on to our last exercise of our first chapter, real numbers for grade 10. And before we move on to our exercise 1.4, let's discuss some important facts which are really useful for this exercise. So let's move on to our first point, and that is, let x is equal to p by q where q not equal to 0 be a rational number, and if the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then x has a terminating decimal expansion. Now this have a converse also. What will the converse be? If x is a rational number having a terminating decimal expansion, then x can be written of the form x is equal to p by q, where p and q are coprime and q not equal to 0, and the prime factorization of q will be of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. So now let's move on to the second important point, that is, let x is equal to p by q where q not equal to 0 be a rational number, and if the prime factorization of q is not of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then x has a non-terminating repeating decimal expansion. Now same way this also have a converse. What will the converse be? If x is a rational number having a non-terminating repeating decimal expansion, then x can be written of the form p by q where p and q are coprime and q not equal to 0, and the prime factorization of q is not of the form 2 raised to n into 5 raised to n, where n and m are non-negative integers. Now the next important fact is, the decimal expansion of every rational number is either a terminating or non-terminating repeating, and the decimal expansion of every irrational number is always a non-terminating, non-repeating. So these are the points which you need to keep in mind while doing our exercise 1.4. So let's move on to our first question. So this is our first question. Without actually performing the long division, state of the following rational number will have a terminating decimal expansion or a non-terminating repeating decimal expansion. And the first question given is 13 by 3125. How will you check whether a given rational number has a terminating decimal expansion or a non-terminating repeating decimal expansion? You just need to check whether the denominator can be written of the form 2 raised to n into 5 raised to m. So let's check whether this can be expressed in the form 2 raised to n into 5 raised to m. So how can I write this? I can write this as 13 by, instead of 3125, I can write it as 5 raised to 5. Now I want to bring the 2 also in the denominator. So what do? I can write it as 13 by 2 raised to 0 into 5 raised to 5. Isn't it correct? And now we have got the denominator in the form 2 raised to n into 5 raised to m, where n is equal to 0 and m is equal to 5. So what can you say about this given rational number? It has a terminating decimal expansion. So how do you write? Since q is equal to 3125 can be expressed as 2 raised to n into 5 raised to m, where n is equal to 0 and n is equal to 5, the given rational number 13 by 3125 has a terminating decimal expansion. So this is our answer. and this is how we check whether it is a terminating decimal expansion. So now let's move on to the next question. So this is our second question, which is 17 by 8. Now how can you write the denominator 8 as? You can write it as 17 by 2 cube. Now how can you bring the power of 5 here? You can write it as 17 by 2 cube into 5 raised to 0. So how do we write the answer? Since q is equal to 8 is of the form 2 raised to n into 5 raised to m, where n is equal to 3 and m is equal to 0, then the rational number 17 by 8 has a terminating decimal expansion. So that is our answer for question number 2. Now let's move on to the next question, question number 3. So this is a third question, which is 64 by 455. Now how can you split the denominator into its prime factors? Let's see. You can write it as 64 by 455. You can write it as 5 into 7 into 13. These are the prime factors of 455. Now, is this of the form 2 raised to n into 5 raised to n? No. So, how do you write? Since q is equal to 455 is not of the form 2 raised to n into 5 raised to m, 64 by 455 has a non-terminating, repeating decimal expansion. So since here the denominator is not of the form 2 raised to n into 5 raised to m, the given rational number 64 by 455 has a non-terminating, a repeating decimal expansion. So now let's move on to our next question, question number 4. So this is our fourth question, which is 15 by 1600. How can you simplify this 15 by 1600? It can be written as 5 3s are 15, 5 3 20s are 1600. Now how can we split this 320 into its prime factors? You can write it as 3 by 2 raised to 6 into 5 raised to 1. So since our q is of the form 2 raised to n into 5 raised to m, where n is equal to 6 and m is equal to 1. Then our rational number 15 by 1600 is having a terminating decimal expansion. So that is the answer for our fourth question. Let's move on to our next question, question number 5. Now this is our fifth question, 29 by 343. Now how can you write this 343 in terms of its prime factors? You can write it as 29 by 7 cube. Now this is not of the form 2 raised to n into 5 raised to m. So how do you write the answer? Since q is equal to 343 is not of the form 2 raised to n into 5 raised to m, the rational number 29 by 343 has a non-terminating, repeating decimal expansion. So this is our answer for our fifth question. Let's move on to our next question, question number 6. Now this is our sixth question, which is given as 23 by 2 cube into 5 square. Now here our denominator is already of the form 2 raised to n into 5 raised to m. So how can you write the answer? Since q is equal to 2 cube into 5 square is of the form 2 raised to n into 5 raised to m, 23 by 2 cube into 5 square has a terminating decimal expansion. So this is our answer for our sixth question. Let's move on to our next question, question number 7. Now this is our seventh question, which is 129 by 2 square into 5 raised to 7 into 7 raised to 5. Clearly the denominator is not of the form 2 raised to n into 5 raised to m. So what is our answer? The given rational number has a non-terminating repeating decimal expansion. So how do you write? Since q is equal to 2 square into 5 raised to 7 into 7 raised to 5 is not of the form 2 raised to n into 5 raised to m, 129 by 2 square into 5 raised to 7 into 7 raised to 5 has a non-terminating repeating decimal expansion. So that is the answer for our question number 7. Let's move on to our next question, question number 8. So this is our question number 8, which is 6 by 15. How do you simplify it? It is 3 2s are and 3 5s are. So you have got it as 2 by 5. Now how can I write this 2 by 5 as? You can write it as 2 by 2 raised to 0 into 5 raised to 1. So here, since q is of the form 2 raised to n into 5 raised to m, where n is equal to 0 and m is equal to 1, 6 by 15 has a terminating decimal expansion. So this is our answer for our 8th question. Let's move on to our next question, question number 9. So this is our question number 9, which is 35 by 50. How can you simplify that? 5 7s are 35 and 5 10s are 50. Now how can you write 10 as its prime factors? 7 by 2 into 5. So here, since q is of the form 2 raised to n into 5 raised to m, where n is equal to 1 and m is equal to 1, the given rational number 35 by 50 has a terminating decimal expansion. So this was the answer of question number 9. Let's move on to our next question, question number 10. So this is our 10th question, which is 77 by 210. Now how can you simplify this? It goes by 7, so it becomes 11 by 30. Now how can you prime factorize 30 as? You can write it as 11 by 2 into 3 into 5. Now is this of the form 2 raised to n into 5 raised to n? No. So how can you write the answer? Since q is not of the form 2 raised to n into 5 raised to m, the given rational number 77 by 210 has a non-terminating repeating decimal expansion. So that was our last subdivision of our first question. Let's move on to our next question, which is question number 2. This is a second question, which is write down the decimal expansion of those rational numbers in question number 1 above which have terminating decimal expansion. So our first question, 13 by 3125, had a terminating decimal expansion. So let us find out how to find the decimal expansion. So how can we write this 13 by 3125? I can write it as 13 by 5 raised to 5. Now to find out the decimal expansion, it is always easier to bring our denominator into some power of 10. Now here it's already the fifth power of 5. So how can I make it as some power of 10? I multiply and divide by 2 raised to 5. So what do I get? I get it as 13 into 32 by 5 into 2 raised to 5, which is equal to 416 by 10 raised to 5. So now it is easier to write the decimal expansion. What do I get? I get it as 0.00416. So this is our answer. Let's move on to our next question. So this is our second question, which is 15 by 1600. Now how can you write it as? You can write it as 15 by 2 raised to 4 into 10 square. Now how can you bring this denominator into some power of 10? You can multiply and divide by 5 raised to 4. So this becomes 15 into 5 raised to 4 by 2 raised to 4 into 5 raised to 4 into 10 square. So this becomes 15 into 625 by 10 raised to 4 into 10 square. So this becomes 9375 by 10 raised to 6. Now how can we write the decimal expansion? This is equal to 0.009375. So this is our answer. So let's move on to our next question. So this is our third question, which is 17 by 8. Now how can you write this as? You can write it as 17 by 2 cube. Now in order to make the denominator into some powers of 10, what can we do? We can multiply and divide by 5 cube. So what does this become? 17 into 5 cube by 2 into 5 the whole cube. So this is equal to 17 into 125 by 10 cube. Now what is 17 into 125? That is 2125 by 10 cube. That is equal to 2.125. So this is our decimal expansion of 17 by 8. So now let's move on to our next question, question number 4. So this is our fourth question, which is 23 by 2 cube into 5 square. So how can we make the denominator into some powers of 10? Already 2 cube is there, but 5 power is 2. So what should you do? You should multiply and divide by 5. So into 5 by 5. What do you get? 23 into 5 by 2 cube into 5 cube. So that is equal to 115 by 10 cube. So what do you get the answer as? 0.115 is our decimal expansion of the given question, 23 by 2 cube into 5 square. So let's move on to our next question, question number 5. This is our next question, which is 6 by 15. So what do we do first? We can simplify this by 3. So what do you get? 3 2s are 6 and 3 5s are 15. Now to bring it to the power of 10, what do? We multiply and divide by 2. So 2 by 5 into 2 by 2. So what do you get? 4 by 10. Therefore, our decimal expansion is 0.4. So this is the decimal expansion of our given question, which is 6 by 15. So let's move on to our next question, question number 6. So this is our next question, which is 35 by 50. So what do we do first? We try to simplify that. So this can be simplified by 5. So what do you get? You get it as 7 by 10. So this can be written as 0.7. So what is our answer? The decimal expansion of the given rational number 35 by 50 is 0.7. So now let's move on to our next question, which is question number 3. This is our third question. The following real numbers has the decimal expansion as given below. In each case, decide if they are rational or not. If they are rational and of the form P by Q, what can you say about the prime factors of Q? So what you have to do here, you have to find out whether the given decimal expansion is a rational and it can be written as P by Q form. If so, they have asked you to find out the prime factors of Q. So let's do it. Now here, since 43.123456789 is terminating, isn't it terminating? It stops at 9. So it is terminating. So it can be written in the form P by Q. So what is a P by Q? P by Q is equal to 43.123456789, which is equal to 43.123456789 by 10 raised to 9. Why 10 raised to 9? Because there were 9 decimal points which I took to the left side. So what do I get here? 43.123456789 by 10 raised to 9. I'm writing it as 2 raised to 9 into 5 raised to 9. So what do I get here? I get P as 43.123456789 and Q I get it as 2 raised to 9 into 5 raised to 9. 2 raised to 9 into 5 raised to 9. Therefore, prime factors of Q are, what are the prime factors? 2 raised to 9 and 5 raised to 9 only. So this is how we find the answer. Now let's move on to our next question. Question number 2. And this is part 2 of question number 3, and it is given as 0.120, and it goes on. So what can you say about this given decimal expansion? It is neither terminating nor it is non-terminating or repeating. So is it a rational number? No, it is not a rational number. So how can you write the answer? The given decimal expansion is neither a terminating nor a non-terminating repeating. Hence, the given number is not a rational number. So that's all for today. We have finished our chapter real numbers. So see you in the next class with a new chapter.